Hey, what's up? Uh, I'm back with another video, and this is going to be, the next topic from redox reaction. And I'm here concerned about, making you how actually oxidation number is calculated. That's what, the motive of this video is going to be. So I'm going to help you how you can find out the oxidation number of an element. Okay, so rules to find out oxidation number. This is what the next topic is, which is very important. There's a basic thing you must remember. The one basic important thing is that an atom in its uncombined state like hydrogen molecule, oxygen molecule, copper, zinc, etc. has oxidation number 0. What that mean? As long as an atom is not with any other atom and is not with the some positive or negative charge, it is always having an oxidation number of 0, right? So when I'll take the example, this is going to be much more easier, but let me write the rules so that you have an idea where you need to work out. Second rule says that alkali metals, which is group 1, alkali metals, like I said, they belong to group 1, has oxidation number of +1, right? Because they have one electron in their outermost shell, so they have oxidation number of 1. Third rule, alkaline earth metals, oxidation number is +2. That's for something going to be fixed. You don't have to worry about is there any change. So alkaline earth metal have +2 and alkali metals have +1. So the next rule is that, fourth one, metals can have only positive oxidation state. So metal never going to have negative oxidation state. Talk about the fifth one. Non-metals can have both either positive or negative oxidation state. So non-metals have no problem, exhibiting not only positive but also negative oxidation state. Talk about the sixth rule. Hydrogen in a binary compound with metals have -1 oxidation state. What that means? Let me take an example here. Suppose sodium and hydrogen, they form a compound. So this is the first thing is that this is a binary hydride. This is binary hydride, and therefore and hydrogen is with metal. And that's why hydrogen is going to have a -1. Otherwise, or otherwise hydrogen oxidation state remain +1. So all other situation, hydrogen will have an oxidation state of +1, like H2SO4. Hydrogen is going to have a +1. But in the binary and metallic hydride, hydrogen is going to have a -1. That's very, very important here, -1 and +1. You need to remember that. These are the key points I'm trying to get you through, which you must have in your mind before you even start calculating oxidation number in a compound for any atom, right? But let me write here superoxide. What are superoxides? These are oxides of metal and non-metals, where oxygen atoms are bonded to themselves. Okay, let me take an example here. KO2 is one such example, I remember. KO2 negative. So what happened here? K is bonded to the two oxygen in this particular manner, where what you see out here, that the oxygen is bonded, oxygen is bonded together. So this is a kind of superoxide. So like I was saying, oxidation number is -12 in superoxide. But in peroxide, its oxidation state is -1, and when oxygen is with fluorine in OF2, the oxidation number is going to be +2. Why? Because F is having a -1, so this will have a +2. So these are and let me repeat, if I'm repeating this everything back here about oxygen, in normal oxide, the oxidation state is -2. So I hope you have understand, that oxygen can have oxidation number -2 under all circumstances. Under normal circumstances, it has +2 when it is with fluorine. It has -1 when it is with peroxide, and when it is in superoxide, it has an oxidation number of -12. So this is -12 here. So with that, I have to take another point. I don't know what number it was. Let's take this. Suppose this was 7th number. So now I'm taking halogens exhibit -1, as their most common oxidation state, at their most common oxidation state. But they can also exhibit higher oxidation state. What that mean? Halogen usually have an oxidation state of -1, but it's not necessary that they're going to have only -1. Sometimes they can have higher oxygen state, and that depends on example to example. So these are some of the points. One last thing I need to tell you is that sulfide, sulfur exhibit -2 in their in the sulfides. I hope you have understand everything about the oxidation state. Sulfur exhibit -2 in the sulfides. Okay. So the next one is going to be number 10. In case of ionic species, the oxidation state is equal to the magnitude of charge. Okay, so let's take an example. For example, Cl negative, the oxidation number is going to be -1. Suppose it's NH4 positive, the oxidation number is going to be +1, and so on. Another very important thing, that algebraic sum of oxidation state of all the atoms in a compound is equal to 0 for neutral one, but for ionic species the algebraic sum is equal to charge. So this is very important line for you. I must tell you here, though I feel like I'm doing a bit awkward here, but I have to finish this. Let me repeat back the whole. In an ionic species, the oxidation number is equal to the magnitude of the charge, and in a neutral compound, oxidation number of all the atoms is going to be equal to the 0 for a neutral one. But if it is an ionic one, then algebraic sum of all the constituents are going to be equal to the the magnitude of the charge. Suppose the question is, find the oxidation state of phosphorus in H3PO4, right? So what I will do, the answer is going to be as per the last line. If you remember, for hydrogen I told you it's going to be +1, so this is 3 into +1 plus X, that is we have to find it, and plus oxygen under normal condition as -2, so 4 into -2. Let's solve this, and that's going to be equal to 0. Why 0? Because this is a neutral species. So if you solve it, this is going to be 3 plus X plus -8 here equal to 0. Then X is going to be 8 minus 3. So that's what is coming out to be 5. So the oxidation number of phosphorus is 5 here. So that's how we use it. Let's take another example. if this is about, MnO4, I'm taking second question here. Question number 2, and that's going to be for MnO4 2 negative. So we have to find out for Mn. So what I will do, X plus 2 into, because for oxygen it's -2, so 4 into -2 equal to -2. Why -2, not 0? Because the magnitude of total charge here is going to be 2 minus. Let's solve it. So this is going to be like X equal to 4 to the 8 minus 8. This is going to be like a +1 here, so going to be 6. So that's how we find out. So I hope with this you have understand what oxidation state is, how oxidation number is calculated, and I have tried my best, though it was a little bit weird. I did it in a very strange way, but I had to. So let me wind this up here. I need to be a little bit formal with you. I have tried my best to make you understand what are oxidation state, how they are calculated, what are the general rules you need to remember. In case you do let me know how good or bad this was, because that's where I get to know, if I'm really working hard and it's worthy or not. So I must tell you, thanks for watching, take care, and good night.